Welcome, ChemComm. One way to understand matter or a substance better is to look at the components of that substance and even make a mathematical calculation as to how much of each component makes up. Today we're going to look at that mathematically in 2.9% composition. So our goal today is to take percent composition and apply that to chemistry. But before we get there, understand that a percent of anything is the part over the whole. You'll hear me say that a lot over the next couple weeks because we're going to be dealing with percent composition for a while. So what you would always do is take the part that you're looking at and divide it by the whole substance and then multiply by 100. For instance, if I gave you a bag of M&Ms, you'd be very happy. And then I said, what's the percentage of green M&Ms in this bag? You would count all the green M&Ms and you divide by the total number of M&Ms, and that would tell you the percent of how many M&Ms you had. That's exactly what we're doing in this section, but just with chemical formulas. Here's an example of where percent composition can be helpful. In quarter 4 of this school year, we're going to start talking about petroleum and the things that we pull out of the ground in oil. Every barrel of oil has different types of fuel within the barrel because there's different fractions in that petroleum. So if you look at this barrel of petroleum, you can see that there's different parts of that barrel that can be used for different types of fuel. This would be a perfect place to do a percent composition. Another place we can do percent comp is just with standard materials laying around the house. So for instance, if you have a penny past the year 1982, it should be about 2.500 grams, and it shows you we have 2.4375 grams of zinc and 0.0625 grams of copper. And so you could do the percent composition for each element. How would we do that? We put the part that is zinc over the total mass, and then we'd multiply by 100 to take the percentage in the decimal form to the percent form. We'd also take the part that is copper, put it over the total mass, and multiply by 100. After we work through that math, you can see that we have 97.5% zinc and 2.5% copper. Couple things. First of all, as long as you're dealing with all the parts, you should understand that those two things should add up to 100% of the substance, right? Also, you can check to see if they make sense because you can look at your numbers and say, okay, we got 2.4 grams out of the 2.5. That would be a very high percentage, which is what we calculated it to be. Another way to do this is if you're given the percentage outright. If you know the total, you can just multiply the total by the percentage, and that'll give you the mass of each part. So if we're dealing with a dime, the total mass is 2.268 grams, and we can multiply by the percent that is nickel. Notice that I've moved the decimal point over 2 spots, so 0.0833. And we can multiply by the percent that is copper. So after we do that math, we can see that we have 0.18 grams of nickel and about a little over 2 grams of copper. To check yourself, you should be able to add those two amounts together and get back to the total mass that we started with, which if you look, that's the way it worked out. So we know we've done it correctly. So the question becomes, how is this helpful in chemistry, or how is this helpful in the real world? One way we can take a look at this is in the industry of mining. When you're mining for, let's say, copper ore, you want to make sure that you're going after the ore that has the highest percent comp of copper. For instance, we have 4 different types of ores here. We have boronite, chalcocite, chalcopyrite, and malachite. If you notice, they all have copper present in the mineral. What we want to know though is as we're digging these out of the ground, which one of those minerals is most cost effective for us to dig out of the ground. So we need to calculate how much metal or what percent of each of those minerals is copper. If we take a look at our first mineral here, chalcocite, we want to figure out how much copper is present in this substance. We have to do this by mass, which means you're going to need your periodic table. So the first thing we need to do, which we've already done, is calculate the total mass of Cu2S, copper sulfide. So we have a copper, and there are 2 of them, and the mass of each copper, if we look on our periodic table, is 63.6. And then we have sulfur, and there's only one of them. And we can take that and look at our periodic table and see that each sulfur is 32.1. And now we're going to add those all together. So now, because of the way we've done the math, we can see each part, the copper and the sulfur, and we can also see the total, the 159.3. So to figure out how much copper is in this thing, we're going to take the part that's copper, divided by 159.3, and multiply by 100. So that gives us an answer of 79.8%. Couple things to note here. First of all, my total mass is everything added together. And second of all, the copper that I'm using has to include both coppers because there are 2 coppers in the formula. And I want to count for both of them. So now let's compare that to a different mineral. Does it have more copper in it than bornite or less copper in it than bornite based on the mass calculations? So we can see that we have 5 coppers, 1 iron, 4 sulfur, and we've added them all up to get 501.63. And now we need to take the part that's copper and divide by the total. And that gives us 63.3%. So at first glance, you may look at this formula and say, oh, that has 5 coppers. That's way better. But when you do the math, because there's other things attached to those 5 coppers, by mass, chalcocite has a higher percentage of copper in the mineral. So therefore, it would be more valuable to us to mine chalcocite than bornite. We can also compare it to malachite. With oxygen, you need to be a little careful. There's 3 here, and then 2 times the 1 in the parentheses would give us a total of 5 oxygen. Same thing with the hydrogen. This 2 applies to the hydrogen as well, so 2 times the 1 that's invisible here would give us 2 hydrogen. We can see here based on my calculations that malachite has even a lower percentage of copper and therefore would not be the best mineral to go after if we owned a mining company. So to answer that final question, what we found out was that chalcocite, because it has the highest percent composition of copper within that mineral, would probably be the one that would be mined most profitably. Now there's some other considerations that would have to be taken into account, but that's a good place to start when you're thinking about applying this information to a real life situation. Hopefully today you learned a little bit about percent composition and why it can be helpful to scientists. Make sure to practice the math and know how to do a percent composition problem. Good job today. We'll see you soon.